Hello, this is Charlie from High Voltage Robotics, presenting the 4th episode of VexIQ Tutorials Volume 1. In this video, you will be learning about the different kinds of PTOs, their pros and cons, and how you can use them on your robot. Before we get started, remember to like and subscribe. It helps us make videos like this for you to learn from. Section 1. What are PTOs? Let's start by finding out what PTO stands for. PTO stands for Power Takeoff, which represents a mechanism that allows one motor to control two different functions separately. In other words, it would allow one motor on your Vex robot to power two different mechanisms. So on a 180 mix and match robot, it would power both your 180 mechanism and your beam lifting 4-bar at different times, using only 2 motors instead of 4. So PTOs can be very useful in saving motor power. Sometimes PTO mechanisms can also be called motor sharing mechanisms. However, there is a large variety of motor sharing PTO mechanisms. So in the next 6 sections, I'll teach you the large variety as well as their pros and cons, and if you should use them or not. I'll also list them in order of least complicated to most complicated. Section 2, Gravity PTO. The Gravity PTO is the most simple, but one of the least effective and efficient. It uses a motor's spinning direction to tilt a beam with spinning gears in one direction or the other. When it tilts to one side, the spinning gear turns a gear connected to the first output you want to power. If it is tilted to the other side, it spins a second gear connected to the second output. Here are some pros. It is lightweight and doesn't require pneumatics. The cons are, each output can only spin in one direction and is unreliable due to gear skippage. It is not recommended for competitive teams, but for new teams it is a good starting place. A good example of a non-PTO version of it was partially used on the 2024-2025 Rapid Relay Hero Bot, Swish. Section 3, Piston PTO. This is easily the most common and most used PTO, which uses a singular pneumatic piston to switch the outputs of a motor. It usually works like the Gravity PTO, but it uses a piston to switch outputs instead of a motor's momentum. It is also more efficient and more effective than the Gravity PTO. Here are the pros. It is compact, it is lightweight, and it is very consistent. The cons are it requires pneumatics and it is not fit in some robots. It is a very good PTO design for teams, especially for those learning about pneumatic PTOs. Section 4, Chain PTO. Before we get started, I would not recommend this PTO for any team, but I'll still include it in the tutorial. It uses a piston to push a very loose link of chain towards a small sprocket. The small sprocket will spin when the piston expands and pushes the chain, and it will stop spinning when the piston retracts. The only pro is it is very simple, but the cons are it takes up a lot of space, it requires pneumatics, and it is very inconsistent and unreliable. And the first output always spins regardless of the piston's position. This is the least effective PTO on this list, so do not use this on your robot unless you have experience and you are able to tune it perfectly. Section 5. Slide PTO. The slide PTO is mostly used on competitive robots, like the full volume meta or rapid relay meta. It works by sliding lower power gears back and forth between 2 gears that act as outputs. It uses pneumatic pistons to create the back and forth motion. Here are the pros. It is compact, very effective, and will be compatible with most designs. The cons are it requires pneumatics, it is a little bit heavy, and it is a little bit more complicated. I wouldn't recommend this for beginner teams, but for competitive teams, it is a good option. Section 6, Ratchet PTO. The Ratchet PTO is one of the most complicated of the bunch. It uses a system of ratchets and gears to control one output when a motor turns left and a second output when the motor turns right. However, it is very outdated due to the introduction of pneumatics and the invention of more effective PTOs. The way it works is, when a shaft connected to a gear spins one way, the ratchet system stays in place and the only output spinning is the first output. But when the motor spins the other way, a ratchet gear gets caught on the ratchet, which uses a whole ratchet mechanism to spin. This causes a second gear attached to the ratchet mechanism to spin, which is the second output. When the second output spins, the first output also spins. Here are the pros. It is easy to build, it is very compact, it is lightweight, and it doesn't require pneumatics. It's also very consistent. Now for the cons. It is a bit complicated, requires Gen 2 parts, and it is difficult to incorporate into a mix and match meta. I would not recommend using this design today, but if you can find an effective way to use it for an efficient robot design, then I'm all for it. For help building a Ratchet PTO, watch an amazing tutorial of link in the description by Riley Merkley. Section 7, Differential PTO. My personal favorite, the Differential PTO. It is the most complicated, but once you get to know it well, it is one of the best options. Here's how it works. It uses a complex system of gears with 2 on one side and 3 on the other to spin a shaft. The shafts are connected via a differential gear, which has 3 smaller gears in the middle that turn each other at a 90-degree angle. When the shafts are spinning in different directions, the small gears inside the differential all turn, so the bigger differential gear does not spin at all. But thanks to the unequal amount of gears on the outside, if the first differential gear's shafts don't spin in the same direction, then the second differential gears have to spin in the same direction. And this means that the 2 small gears on the sides of the differential spin in the same direction, so they are both pushing on the center gear. This causes the entire differential to spin in whatever direction the shafts are spinning. So, if you take advantage of the gear shape on the differential gear's outer rim, then you can attach a 36-tooth gear to both sides and use that as your outputs. And of course, to get the shafts to spin like that, you'd attach motors to the outside gears, and the code will do the rest. If you're a bit confused, I'd either work with a different PTO design or watch a different tutorial on differentials. I've linked a good one in the description for you to learn from. Now, here are the pros. It is compact, it doesn't require pneumatics, and is extremely consistent and efficient. And it's also a genius design, so it will have a good spot for Innovate Award or for your notebook. The cons are, it is very heavy, it requires differential gears ordered off of vexrobotics.com, and is extremely complicated. I definitely wouldn't recommend for beginner teams or rookie teams, but for more advanced teams, it is a great design. Section 8, How to use PTOs. Now that you know all the PTO types, what kind should you use, and where should you use it? If you're a beginner or rookie team, or you have at most 2 years of experience, start with something simple. Choose a Piston PTO or Gravity PTO. If you're a more experienced or competitive team, choose a Slide PTO if you want a simple, lightweight PTO, or a Differential PTO for a more efficient, non-pneumatic, more complex PTO. And if you want to use the more compact or Ratchet PTO on your robot, suit yourself. And one more thing, never use the Chain PTO on a competitive robot. So now that you've hopefully chosen a PTO for your robot, where should you use that PTO? Well, this season, the only modes you can really use a PTO on are the 180 mech robot and Ben Lipper's pinhead robot. It is difficult to use on a conveyor due to the conveyor's awkward angle. A Slide PTO, Piston PTO, or Differential PTO could be used on the pinhead or 180 mech robot, allowing 2 extra motors for the drivetrain or for the intake or lift. And for any compatible robot with 2 mechanisms, you can save 2 motors by using a PTO. And that's all for PTOs and motor sharing. I hope you learned something new today. I hope everyone has had a good holiday season, and now it's 2026. Our New Year's resolution is to reach 200 subscribers by 2027, and you can help. Please hit the like and subscribe button. We worked extra hard on this one. The script had over 1,600 words. It would really help. Visit highvoltagerobotics.org and join our Discord. Link is in the description. Thank you for watching, and have a happy New Year.